Now chapter 11, dual nature of radiation and matter. What it is says that basically radiation means light. Light has dual character, and matter means electron, proton, like that type of things you can take. So matter also having two character. Matter inside matter now we also comes. We also consider as a matter. We can have also two character. One is wave character, another is particle character. So all these things we will understand in this chapter. Please try to come to topics to be covered. Introduction, electron emission, Hertz observation, Howell's and Lennard's observation, experimental study of photoelectric effect, failure of wave theory of light. See, wave theory of light cannot explain photoelectric effect. That is the reason we went to particle character of light. Next, Einstein's photoelectric equation, particle nature of light, wave nature of matter. It is a de Broglie, right? This one is a de Broglie. De Broglie relation. See, this de Broglie now is a scientist. In 21 years old, he told that light can have two characters. Light can have two characters. Are you getting or not? Light can have two characters. In that two character, one is wave character, another is particle. Clear or not? So de Broglie. All of you listen. Now Davison and Germer experiment. Then this Davison and Germer experiment, listen. This one supports this experiment. De Broglie relation. Wave nature of matter. It is basically supported by what? Now Davison and Germer. Davison and Germer. Clear idea? Yes or no? Okay. Now next listen. So this many topics are there. First we'll start from this topic. Introduction. And what happened here? Okay. That one page only happened like that. See, this is history only. You just read once. What is written? You just read once. I'll talk to HM sir. What happened? I'm coming. Not visible. Just one. See everyone, this one actually nice history was there. So some slide changes happened. Actually this one I can read actually. You see here. The discovery of X-ray by Röntgen in 1865. 95. Very good. 1895. Very good. Now the discovery of electron by J.J. Thomson in 1897. Very good. Now what is this one? Tell what is this one? The cathode rays. Cathode rays were discovered in 1870 by William Crookes. See, this will develop your mind. Notes are changed, right? But it will develop your brain, inside brain. You will be sticking to the presence of mind. Okay. One point. Hemavati, stand up. This point you read. What is this one? You read this one. We'll see how your brain is working. The presently accepted value of electron charge by mass is 1.76 into 10 to the power 11 coulomb by kg. Okay. That means your left side brain, right side brain, everything is working. Very good. Excellent. Give. Clap. Okay. Now listen all of you. Certain metals when heated to a high temperature were found to emit negatively charged particle. Certain metals, if you heat now, metal is there. Hey boys, certain metal is there. If you heat now, what will happen? They will emit charged particle. That is called electron. What that is called? Electron. Okay. So when a metal will emit electron, if that electron will collect now, then what will happen? We will keep one circuit now. Then what will happen? One electron flow can happen in a circuit. So it can become a closed circuit. That is basically photoelectric effect. We'll see this one. Wait. Now see. Electron charge, it is mass, electron charge to mass ratio of this particle. This is called basically charge to mass ratio. or it is called specific charge. What do you call? Specific charge or charge to mass ratio, E by M. See, J.J. Thomson in 1897 named these particles as electrons. From metal when light falls, electrons are coming out, or one negative charge particle coming out. That negative charge particle, what you call? Electrons. J.J. Thomson named this. Now next come electron emission. See, there are how electron will emit. There are three processes. Electron emission. Okay. Electron emission, three processes. We will see that one. Electron emission is the ejection of an electron from the surface of a metal. I told you, if it is a metal, if this is electron, one electron is coming out. So ejection of electron from a metal is called electron emission. There are three processes. You read this one. I am just checking here. 1 minute. You are sitting simply. You are stopping. Okay. That is what I am not stopping. Who is stopping that? So the emission of electron emission is the ejection of an electron from the surface of a metal. Or in other words, you can tell, if electrons are ejected from a metal, this process is called basically what? Electron emission. You told correctly, right? Sit down. Very good. Mamita Sri, stand up. How many processes are there for electron emission? How many processes? Three processes. What are the names you tell? One is thermionic emission, another is field emission, another is photoelectric emission. Okay. Moshini, how many emission processes are there? Stand up. Three processes. One is thermionic emission, another is field emission, another is photoelectric emission. Listen, I don't read everything, but by seeing the language now, I can remember everything. Sit down. Now they told what? Thermionic emission. What do you mean by thermionic emission? Thermo means heat. Heat energy you are giving. So you are heating certain element or metal. By heating the metal, you are giving energy. From that metal, electron is coming out. That is called thermionic emission. And the electron comes out, that is called thermions. What do you call? Thermions. That means what happened here? Everyone try to understand. What happened here? This is a metal. This is a metal. In this metal, you are heating. You are giving heat. Now, what happened? Now, from here, you have energy levels. These all are electrons. Now, this electron came out. Because when electron will get energy, it will go to higher excited state. So, now electron coming out. Now, this electron I will tell as fermion. What I will tell? Fermion. And this total whole process is called basically what? Thermionic emission. Clear? Not a single doubt also. Now I will read the statement. By suitably heating, sufficiently thermal energy can be imparted or can be given. Imparted means can be given to the electrons to enable electron come out of the metal. Okay, but they did not tell about fermions. You can write here. Star mark point right here. The electrons emitted are called. The emitted electrons are called. Right. The emitted electrons are called fermions. Now next, field emission. Field emission means you are removing electron by applying high electric field. Okay. And how much that high electric field? That high electric field is 10 to the power 8 volt per meter. How much mass, Nagapriya? What is the electric field? Magnitude? 10 to the power 8 volt per meter. Why volt per meter? Why volt per meter? Because it is a SI unit of what? SI unit of what? SI unit of me or you? SI unit of electric field. Remember, electric field I am telling now. Your strong electric field. So electric field value should be 10 to the power 8 volt by meter or Newton by Coulomb. Because electric field is basically potential by distance. Okay. So remember, 10 to the power 8 Volt by meter or Newton by Coulomb. Now photoelectric emission. What is photoelectric emission? Now when light of suitable frequency illuminates a metal surface, electrons are emitted from the metal surface. These photo generated electrons are called photoelectrons. See, photo means light. So with light you are removing electron from the metal surface, but by applying what? Light energy, photons. Clear? No doubt. So that is called photoelectric emission. Photo means light. You are removing electron, due to that one electric current is coming. So that's why photoelectron came or photoelectric came. Emission means moving out na. The process of removing one electron from the metal surface is called emission, electron emission. So that's why emission word is coming. So everyone remember these three. You will never forget. Throughout the life also not forget. Actually my physics teacher taught like this to me in 12th standard. That's why I remember like that. Without, my language is there, I can read this, but I am not reading because my teacher put in my brain like that only. Till now I don't forget. Okay, so you should not forget. Now next listen. Next everyone listen. Photoelectric effect. You take care of this. Photoelectric effect. All of you listen. Direct photoelectric effect was there after emission. Okay. All of you listen here carefully. This is your metal surface. These are metals. Negative charge basically electrons. This is basically incident light. When incident light falls on the metal surface, electrons are ejected. What you call, Bhuvana, these electrons? What do you call? What do you call this name? What is the name? Like, I did not ask you. Don't talk. What is this name? Ejected photoelectron. Don't read from there. You tell directly. Tell it is photoelectron. What it is? Photoelectron. The electron which comes out of the metal surface by applying the light, that electron name is what basically? Photoelectron. Photo means light. Photo meaning is light. So why I am telling photoelectron? Now because due to light only that electron came out. That's why name is photoelectron. Now understood? Sit down. Now next listen. It is written what is photoelectric effect. I'll read the language, no worries. The photoelectric effect is a phenomenon in which electrons are ejected or electrons are removed from the surface of metal when light is incident on it. And the ejected electrons from the metal surface are called basically photoelectrons. What do you call? Photoelectrons. Understood? Photoelectrons. So definition will come, 1 mark definition, photoelectron, you can say that. Now I'll go to the next. This one you are able to understand. Light is coming. This all are in energy level. The all electrons are in different energy level. Now when light is falling, electrons are coming out. Clear? Okay. See, preparing like this activities and showing you, it is not one day work. So please you respect this. Don't talk. This is work of 1 year or 1 month or 2 year or whole life. Somebody has worked and kept like this. I only created this one. So please respect that. Respect. When this is there na, you should shut up your mouth. Okay? Pin drop silent, boys. So in your NCERT book, how the experimental arrangement of photoelectric is given na, this one taken from NCERT book. So if suppose in your exam they are asking draw the experimental setup of photoelectric effect, then you have to do this diagram. What is present here? Now here this one you have a glass tube. What you have? You have a glass tube. This is a glass tube. This is a glass tube. Now light is coming here. Mostly we taken UV light. UV light coming here. Now here you have a metal. Here you have metal. That is called cathode. What do you call? Cathode. When light falls on cathode, like how I have shown you before na, electrons will come out. These are the electrons. Pin drop silent. Pin drop. That means pin drop means what, you know? If I'll put a pin here, it should make sound. That sound should be audible by everyone. Okay, if anyone talks na, it will be not audible. That is the meaning of pin drop silent. You ask in English. Pin drop means what? Pin drop silent. When pin falls na, that sound should come to everyone's ear. Sound came? To whom sound did not come? Silent. Now next listen. Glass tube, UV light is coming. This one is called photosensitive plate, or basically cathode, you can tell. This is your A. A stands for anode. A stands for, okay, one more thing. In Tamil Nadu, what pronunciation you do for cathode? Cathode. For anode? Anode. So I am pronouncing same because my state is different now, Odisha. So what I am telling, if anything is comes na, you just tell me. Say Tamil Nadu, we pronounce like this. Now next listen. See here, all of you. Your volt. Now see, here it is anode. Now this cathode electrons are coming. Now what I told, if electrons are coming now, we should receive the electron. How to receive the electron? Now electron, suppose electron is coming, how to receive the electron? Electrons are negative charge. So if we keep in front of them positive charge, it will be getting attracted to that. So that's why I'll make this plate as positive plate. This plate is what plate? Positive plate. If this one is positive plate, then what will happen? This all electrons will be attracted towards this. Then if I'll keep on circuit here, then what will happen? Now in this circuit, current will flow. Current will flow because charge particle moving now, electron moving here. If electron is moving, current will flow in this way. I will flow opposite way. Are you getting or not? That means by light we can emit electron. That electron we can receive by anode. From that we can constitute electric current. That means what happened? From light what came? From light what came? Electric current. So this is called photoelectric effect. Clear? And the explanation to this photoelectric effect was given by Einstein. How this light electron current came? All explanation was given by whom? Einstein. While considering Einstein now, that time he considered that light is a particle. Then only he explained everything. But before Einstein, some uneducated fellow came. Don't tell uneducated fellow. They are educated actually. They tried to explain this, but they are not able to explain properly. They are not able to explain properly because they are considering light is a wave. What they are considering? Light is a wave. So their point of consideration was different. That's why some fellows like Frank Hodge, Halves, Leonard, I told the names na, they came to explain this, but they are not able to explain. They just told that experimental setup, experimental features. They are not able to explain properly. But Einstein explained properly due to this perfect explanation that whatever Einstein explained. In 1905, he got Nobel Prize. What he got? Nobel Prize for photoelectric effect. Nobody got. Other people did not get because they are not able to explain that light is a particle. Light is coming like this. Because of this graph is coming like that. Nobody was able to explain. But everybody was able to see the observation. In observation, graph was coming correctly. But nobody was able to explain that graph. But Einstein correctly explained. Understood? Now that fellows, those who did not understand properly and took light as this one, that one will try to understand little. Their experimental observation, what they did groundwork. But they helped Einstein to get Nobel Prize. Because groundwork they did. They did groundwork, they understood what is the observation. So now everyone, come and see what they did. Let's see what is the next page is there. Next page is there. So here in photoelectric effect, who is the hero? Who is the hero? Einstein. Einstein is the hero. He only explained properly. Now it is written what is photoelectric effect, because some question can come also in your exam. What is photoelectric effect? Draw the diagram. That diagram you have to draw. You practice well. It is there in classwork. See, the phenomenon of photoelectric emission was discovered in 1887 by who? By whom? Heinrich Hertz. during his electromagnetic wave experiment. You remember who discovered electromagnetic wave? Who discovered electromagnetic wave? Heinrich Hertz, Heinrich Rudolf Hertz. Same people also wanted to work on photoelectric emission. Next, in his experimental investigation on the production of electromagnetic wave, in his experimental investigation on the production of electromagnetic wave by means of a spark discharge, Hertz observed that high voltage sparks across the detector loop were enhanced when the emitter plate was illuminated by UV light. So what he told, that he saw some spark. That spark will be more when UV light is falling. Okay, that means this experiment of photoelectric effect was initiated by whom? Hertz. But credit who took? Einstein. Like you understand, Krishna Priya ma'am taught everything here, and Krishna Priya ma'am went left to school, right? Huh? Now, for Devakrishnan, 99 came result in English. Then that 99 will be appreciated to whom? Who is present English teacher here? But actually who did it? Krishna Prema. Did you understand or not? Now clarity is coming. Clarity is coming or not? Clarity is coming or not? Now next, conclusion. What is conclusion? When light falls on a metal surface, some electrons near the surface absorb enough energy from the incident radiation to overcome the attraction of the positive ions in the material of the surface. Okay, one example I gave, you don't take depth. That is just student are giving result, not teacher is responsible. Because last year also Krishna Prema was there, but English mark was 91 highest mark. Why? Are you getting or not? So result who is giving? Who is giving result? Student. Credit should given to student. Teacher is just a helper, just helping them to study. Understood or not? Now recording, no worries. Now next listen. I am telling the correct thing. I am telling why I will get fear. Now conclusion. When light falls on a metal surface, some electrons near the surface absorb enough energy. Enough energy. So when light is falling on the surface, conclusion, frankly telling, it will absorb more energy. So here metal, in this metal, when light is coming now, this is absorbing energy, electron is absorbing energy. Next listen, who is talking? Don't talk. Now, after gaining sufficient energy, incident light, from the incident light, electrons escape from the surface of the material into the surrounding space. Now after gaining more energy, this electron is coming out. Electron is coming out of the surface. Electron is coming out of the surface. Yes or no? Now these electrons are called photoelectrons, already you know. Now next listen. Holwas and Leonard, they are scientists. In 1886 to 1902, they observed one experiment on photoelectric effect. And you tell, sir, this one shall we study or will not study? You study, because they did groundwork for photoelectric effect. Now next listen. Leonard's observation, and for everything now, I will tell two observation and one conclusion. What is the observation? Leonard observed that when ultraviolet radiation were allowed to fall on the metal plate or emitter plate, cathode plate, evacuated glass tube enclosing two electrodes, current flows in the circuit. So photoelectric effect, faster time itself he observed, Leonard. The next what observed? As soon as ultraviolet stops, current flows. No current flows. Current flow also stops. So what is the conclusion? Conclusion is, these observations indicate that when ultraviolet radiation fall on the emitter plate is what? Basically C. Emitter plate is C. So when it falls on emitter plate, electrons are ejected from it, which attracted towards the positive electrode plate. I told this one already. The electrons flow through the evacuated glass tube, resulting in the current flow, and thus light falling on the surface of the emitter plate causes current in the external circuit. So already two observation and two conclusion. Always you have to write for each experiment. Okay. So Holwas and Leonard, both the scientists gave these observations and conclusion. Separately I have distinguished here. So what you do? Two observations you remember and their conclusion also remember. And both looks very similar. Okay. Because the explanation I have given already. Whatever I told, same thing Linard is saying. Now come to the next. Next come to the next. Next come to the next. This scientist observation, okay? You pronounce properly this one. Now here how many observation point is there? Tell. 2 observation, 4 observation, 1 conclusion. What he did, he little modified. He took some gold leaf. That time gold leaf electroscope was available. He took gold leaf and he did some experiment. So this 4 observation and 1 conclusion you read please. 1 minute I am coming. Listen. It is found that certain metals, why did not switch on? Automatically. Why did not switch on? I explain this. Now it was found that certain metals like zinc, cadmium, magnesium, etc. responded only to UV light. Okay. So if UV light falls on these metals, then electrons are coming out. And short wavelengths to cause electron emission from the surface. But some alkali metals like lithium, sodium, potassium, cesium and rubidium were sensitive to visible light. Now you see, question will come. Which of the following option is sensitive to visible light? So one sodium given, it given option like this. Sodium, zinc, cadmium, magnesium. Which is answer? See, I am telling which of the following option is sensitive to visible light? Sodium. Why sodium? Because some alkali metals are sensitive to visible light. So sodium is answered. Why these are not answered? Because these are here. These are sensitive to which light? Ultraviolet light. These are sensitive to ultraviolet light. Understood? Now I'll ask Amrita Bachchan, stand up. Tell me, which materials or which metals are sensitive to ultraviolet light? Zinc, cadmium, magnesium. Very good. How you are telling? You are learning, right? So always you learn, ma. Please, requesting. Request from a teacher to student. Always wave optics, ray optics, whatever things you read, ma. Read means you will remember. Sit down. Now, Mohsin, stand up. Tell some metals which are sensitive to visible light. Potassium, sodium. Tell. Potassium, sodium, lithium. Say next. Any other is there? Cesium, rubidium. Okay, ruby also there. Call ruby also. Ruby also visible, sensitive to visible light. Someone ruby is there, right? That class. So rubidium, remember. So that ruby is sensitive to which light? Visible light. Rubidium is visible light. To remember, how will you remember? Okay. So to remember only I told. Okay. Ruby is there or not? Whose name Ruby? She is sensitive to which light? Visual light. That means you remember rubidium is sensitive to visible light. Now next lesson. Now came to work function. See, everything today I'll teach. Completely I'll complete many 80%, 90% chapter I'll complete. You go and read that, and when free time try to make notes. Okay, because your handwriting you can understand better than others. Yes or no? That what I already posted in group. Now everyone listen here. What listen? All of you listen. Work function. Work function is symbol is phi naught or W. Okay. Sound is come. Work function symbol is what? Phi naught W. Now, what is work function? What is work function? We will try to understand. Meaning is what? Work function. You are telling some function of work. It is not like that meaning. We will understand perfect meaning. What is work function? See, work function is a energy. Work function is what basically? Energy. And before energy writing, always write it is a minimum energy. What energy? Minimum energy. It is a minimum energy. What might is? Minimum energy. Next to what, sir? Now I'll tell you. You can tell definition. See, metal is there. In every metal, there are energy levels. K cell, L cell, orbital. In chemistry, you studied already, na? In metals, some cells are there. K cell, L cell, M cell, N cell, P cell, orbitals also. So, I am telling in metal, one electron is sitting here in one cell. That one I will tell as energy level. What I will tell? Energy level. One energy level, one electron is sitting. Now, if I will see now, it will have certain energy here. Phi naught. What energy? Phi naught. All of you listen. When you are in one place now, you have that energy, that's why you are present there. Phi naught. Now, if a light is coming and giving same phi naught energy, then this electron will come out. Electron is out. Electron is out. Are you getting or not? So that is what is work function? Now work function is the minimum energy required by an electron. This electron, bomb electron sitting here. Okay, it wants to come out. To make it out, the light you should provide. The light you are giving now, you should provide phi naught energy, because it is having phi naught energy there. That's why they are sitting here. To escape from the metal surface is called work function. Now understood clearly? So now definition, I will complete the definition. Work function is the minimum amount of energy required by an electron to escape from the metal surface, or the minimum amount of energy required by electron to escape from the metal surface is called work function. Anything you tell, correct. Are you getting, ma? You are not getting. You are not getting. Getting? That means, like, see, you all are electrons. Now suppose this is one electron. It is having certain energy here. When sitting now, you are relaxed. You are having certain energy. Now if I want to remove you now, I have to apply some external force, external energy. Then I can take you and I can make you out. Are you understanding? Similar way, all electrons. Suppose you tell, sir, this electron, this is also having, this is a phi naught 1 I gave. Number what I gave? Phi naught 1. Now if you want photon you are releasing to the metal, that photon should have phi naught 1 energy. Then only electron can come it out, this electron. So every electron having this phi naught 2. Every electron have a certain different energy. Clear or not? Very good. Bhuvana, stand up. Say what is work function? Very good. Before just 1 second, you did not know this definition, right? Now you came to know. You can explain also, right? So for every metal, see, for every metal, work function will be different. And work function is a material property. Suppose it is a iron metal. For that work function different. If it is a aluminum, for that work function is different. It may have some formula, but it is a material property, you remember. That's why I understood why I told this word to you. Sit down. So remember everyone, work function is a material property. If it is aluminum, see, for aluminum, work function will be different. For potassium, work function will be different. Sir, for all the electrons inside the aluminum, it is same. For all the electron, this is the work function. We'll take like that. Okay. Now next, everyone listen. The work function depends on the properties of the metal. See, properties came. It is a material property. And the nature of its surface. Listen, all of you. Whenever electron is emitting now, surface electron is emitting. Because you remember nucleus. This is the nucleus. This is the electron. This is the outside electron. See, only this electron is far. This electron is less distance. So less distance electrons are bound to the nucleus. Bound to the nucleus by the nuclear force, by the electrostatic force. So it cannot come out. This electron cannot come out easily. This will come easily out. So surface electron only comes out. Okay. So that's why what they are telling. Now they are telling it depends on the nature of its surface. And work function of platinum, I told just now, platinum work function how much? 5.65 electron volt. See, you have here cathode, you have anode, cathode and anode. See here, all of you listen. You have cathode and anode. If this cathode is made up of platinum, then how much energy required to remove one electron? Now energy of this light should be 5.65 electron volt minimum. It can be 6 electron volt, yes. It can be 6, it can be 7, yes. It can be 7, but it should not be less than 5.6. Stand up. Tell what is work function of platinum? High point. Very good. Sit down. What is the EB? EB meaning is electron volt. What volt? Electron. Now everyone leave it. Now come here. Now threshold frequency. Oh, here is there. The highest for platinum, lowest for cesium. See, lowest for cesium. For cesium how much? 2.14 electron volt. See, EV means electron volt. So remember, for cesium 2.14 electron volt. This is energy actually, E. And for platinum, how much it is? 5.65 electron volt. Understood or not? Maximum for metals, and in between range will be there. I think in our book also it is given. I'll show you. 1 minute wait. If it is there, not there, not leave it. One table will be there. Old book it was there. No, not this one. Then it is not given. Not given, you leave it. No worries. You remember this much, you remember. Now next listen all of you. See. Now I want to give you work function, you understood? I want to give the formula for one function. It is given in Xerox. Check work function formula. What given? H nu naught, SC lambda naught. Now listen all of you. Now previously whatever you studied, threshold frequency, threshold wavelength, these all are interconnected. What is work function? Tell. Work function equal to H nu naught, or H nu naught can be written as SC by lambda naught. All of you listen. They will give you 2 electron volt. Work function is 2 electron volt. What is work function? What is F naught? What is threshold frequency? What is threshold frequency? Can you calculate or not? Threshold frequency. Can you calculate? Phi naught is 2 electron volt. What is threshold frequency? How to calculate? See here. Phi naught formula is H nu naught. Nu naught is threshold frequency. Lambda naught is wavelength. So now nu naught is nothing but 2 electron volt. Now nu naught is nothing but 2 electron volt by H. Now 2 into 1 electron volt is 1.6 into 10 to the power minus 19. H value is 6.626 into 10 to the power minus 34. Now you calculate this. Now what you do? Calculate. Now what you will get? You will get nu naught. Similarly, if you want to find lambda naught, you can find also lambda naught. Lambda naught is what? What is lambda naught? Threshold wavelength. What it is? Threshold. How to find that? The threshold wavelength. See, lambda naught is HC by phi. I think you did a mistake here. No, correct, yeah? Correct. H will. Lambda naught. See here. SC is 1240 electron volt nanometer. You remember in mind. Now 2 electron volt. Electron volt cancel. Now lambda naught is coming how much? Tell. Lambda naught is coming 620 nanometer. Correct, huh? See, finding lambda naught is easy. Why you know? Because Finding lambda naught is easy. Why lambda naught is easy? Because HC value I remember. What is HC value? 1240 electron volt nanometer. Already electron volt given, electron volt cancels. Answer coming in nanometer. So remember always, listen, while solving dual nature question, H value remember, C value also separately remember, and HC value together remember. How much it is? 1240 electron volt nanometer or 12,400 electron volt angstrom. Okay. H value, C value will be given in exam question. Question paper it will be given H value, C value. But we know, what do we know? 6.10 to the power minus 34 joule into second, 3 into 10 to the power 8 meter. If you don't know, you write. In dual nature, while doing dual nature, this all data you must remember and keep in brain. Okay. Right. If you not written, write in Xerox. Somewhere you write. Understood? Work function, threshold frequency, threshold wavelength. I completed. H value check now. What is H value? 6 to 3. 6 to 6 also you can take now. Reach. What happened, ma? What tell? What is happening? What you told like this something? 1240. Trick means? Direct remember 1240. One only remember 1240 electron volt. SC only write SC. Here it will be written also that exercise given. Here 6.626. See 6.626. Otherwise you can write. What you know? 6.63. Not 62. 6.63 you can write. It taken here. 6.63 H value. Okay. Huh? One minute. Completed up to this. Say, up to this you remember. Up to this what you do? You remember. And if possible, wave optics you complete in classwork. After that what you complete? Dual nature up to this. You complete. Okay. See, I am not telling that you sit and write. I am not telling. When from heart you feel I want to read physics, that time you should read your notebook. Your notebook should be your handwriting, and your handwriting will come when you will write. Are you getting or not? So you must write. Don't keep in Xerox everything. Must write.